A final example, we have force versus clock time, and we're again going to find the approximate area under the graph and attempt to interpret that. We first assume a linear change between the two given points. Again, that might well not be the case, probably won't be in a varying force case, but again, it's our first approximation. Our time goes from 0.02 to 0.05 seconds, giving us a time interval of 0.03 seconds. Our average force will be the average of the 2,900 newtons and the 7,100 newtons. If we add 2,900 and 7,100, conveniently comes out 10,000. Okay, so that's our approximate average force. If we multiply then the altitude times the width, we see that the area is 5,000 newtons times 0.03 seconds, which is 150 Newton seconds, which we know from our study of impulse and momentum to be 150 kilogram meters per second, units of momentum. And this represents the change in momentum of an object, provided the force F represents the net force. So if F represents net force, area represents net force, average net force, times delta T, which equals delta P, the change in momentum. And you recall that earlier we looked at a graph of momentum versus clock time and found that the average slope of a momentum versus clock time graph was force. So that's the flip side of this analysis.